Ready to record. Now go.
Okay, this is the bookend. This is the monthly St. Louis Linux Unix group, also known as the St. Louis LUG. This is Thursday, the 21st of November, 2024. Welcome. Our speaker tonight will be Stephen Lembark from Workhorse Computing. Stephen did a wonderful presentation last month at our Wednesday night general meeting on a bunch of command line stuff in Bash. And so he's kind of following up on that in a way. It's not really a part two, but more just a similar talk. And he's going to talk about obeying the command line and getops and TypeScript tonight. So we're looking forward to that. But before we get to that, we have a few announcements and also an opportunity for some open Q&A. So let's see, as far as announcements go, I'm just going to pick some stuff off the calendar. And let's see, it is in this past week here, just I think yesterday it was, 55th anniversary of the first permanent connection of the ARPANET, which is what became the internet. And anybody know what that first connection, where the two endpoints of that was? Go ahead, push your microphone button. Da-da-da. Okay, it was between UCLA and Stanford Research Institute, SRI, and then Lembark. So 55 years ago. Hard to believe it's been that long. Something a little more recent, 10th anniversary of SUSE being merged into Micro Focus. And that was a big thing back then. 50 years ago was the beginning of the DOJ, the Justice Department's antitrust suit against AT&T. That resulted in the breakup of AT&T into separate companies and spun off Bell Labs and, of course, spun off Bell Labs ownership of Unix. So, let's see. On STLLUG things coming up on the calendar, next week, specifically next Tuesday, is the newcomers meeting. For those of you who may not be too familiar with it, I'll give a very brief description. The newcomers group basically does not have a fixed presentation. It's basically just whatever people want to talk about. And there's a little informal poll. They decide who the newest user of Linux is, and whoever that person who claims to be the newest user of Linux, he gets to ask the first question. And then everybody bandies about what the best resolution of that is until that's satisfied. And then they go to the next least experienced user. So, but don't think it's just for the least experience. It's having people in there who have some experience, which of course give all these wonderful, wise comments and answers. And amazingly, even if you consider yourself an experienced user, going to that meeting, a lot of times you get involved in what seemed like a simple question, and you get a bunch of other experienced users who have different approaches to it. And you actually can learn quite a bit, even if you're already a few years, more than a few years into using Linux. So that's next Tuesday, and everybody's welcome. Next, let's see, on December the 3rd, it's a Thursday. That's our Slack meeting, St. Louis Area Computer Club. Again, there is not a fixed presentation, so it pretty much is what people want to talk about, but there's always something to talk about. Slack, the computer club, is a little bit more hardware oriented, so it's more talking about, what's in your computer, how it works. Sometimes it's, how do I get Linux to know what's going on with this piece of hardware? But we don't limit it to Linux. Sometimes it's, how do I get Microsoft to know what the hell this thing's doing? So, yep, we'll even talk about Microsoft there. So those are things coming up on our calendar. Anybody else have anything they'd like to point out from the calendar or other announcements?
Yeah, they typed in L and O and then it crashed.
Okay, Ed. An L and O and then it crashed. Can we have a little more context?
Yep, that was the first thing you mentioned.
Oh,
The the connection of the ARPANET, the first thing they wanted to log in, so they had to type in login, but they typed L and O, and when they went for the G, crashy roomy.
It's nice to know nothing has changed in 55 years.
Exactly
You
right.
don't have to type login.
Oh,
Now you get the prompt.
oh yeah. Oh my. Okay. Any other comments, observations? Okay, how about some good questions? And it sounds like I'm stalling, and I am because our speaker stepped out for a moment, and so we've got a couple minutes until he gets back in. So,
Well, I got a good question for people. Been using GNOME for 15 years, and for some reason, they have seen fit to take away shortcuts on the, on the keys, shortcut keys. For example, up until the last version of SUSE, there was a shortcut key for move current window to the up workspace up or down. Well, there isn't in the next version of SUSE. And I'll be darned if I can figure out where they're defined. I'm assuming there's a file somewhere under .config where those keys are, or where they live and where the definitions live. Is anybody any experience with that? Does anybody have any experience with that? Well, I guess that was a real hard question.
yeah.
Yeah, no, you can so if you go under the settings, there's a key. I don't have it loaded up, so I'm not going to know off the top of my head, but in the settings panel, there is keyboard shortcuts, and you can customize the keyboard shortcuts. And I specifically remember customizing the one that you're talking about, so I think it does exist and is possible.
Yeah, but the problem I have is, number one, it's not in the list anymore. So you can't pick it and customize it. And number two, I've tried 5 or 6 different ways to add it in the settings, and it's not there. So what I want to do is, it was a custom shortcut under my existing system, and it still works. And I'm trying to find it in the config file so I can just copy it to the new system. Does that make sense?
You said this was GNOME, right?
Say again?
You said it was GNOME.
Yes, GNOME, current version.
So I have G settings. I think that's the GNOME program. It's a command line program, G settings. And you can it could show you it's all different kinds of schemas. So I mean, that's where I would search. I don't know if your specific problem is in there, but
Well, I don't see any. There's plenty of schemas, keys, values.
well, yeah, you have to pick a schema and then look for the settings in that schema. I think that's how it works. It's been a while since I played with it, but it's fun to play with, because I was looking for a way to do what you just said, which is to pull all my settings and then move them to another machine or something.
Oh, okay.
Are you sure they didn't just change it to left and right instead of up and down?
Left and right are still there,
Right, I think they just
but up and down are missing.
right. I think that's what I remember. They switched from left and right to up and down to be more in line with the trackpad gestures, I think.
Well, but there was no switching. You used to have 4, up, down, left, right, but they took away up and down.
Yeah, but can you even do a workspace up and down now? I thought it was left and right.
I've been doing it for 10 years.
Right,
And
but on the version where they took away the keyboard shortcut, did they also take away the vertical workspaces? Aren't they horizontal now?
No, you can make them vertical.
Oh, you can make them vertical.
Yeah.
And when you make them vertical, do the left and right ones automatically go vertical?
No, they don't work. Well, they don't work because there's nothing to the left and right. See, the basic problem is, if you have multiple monitors, left and right aren't that useful. You need up and down, if you think about it. Because
Yeah,
having left and right when you have 4 monitors sitting next to each other, yeah, but that doesn't give you multiple workspaces. For multiple workspaces, then you need to go up and down.
I mean, I guess I thought it was just more of an animation thing. Does the animation go up or down or left or right? Because like the functionality is the same. Like the functionality of a workspace is the same. It's just kind of, does the animation go left or right or up or down?
Well, and it used to be you had those 4 options in the settings, but now the up and down are missing.
So how do you make it go up and down? You said you could make it go up and down. How do you do that?
I'm saying I have an older version where it works,
Oh,
and I want to find that those key settings in the GNOME settings so that I can just copy them over to the new version. The problem was the new version, I did a fresh install. On the old version, I've done upgrades. So I still have it now. I guess I'd have to try to grep for it or whatever.
yeah.
Because
Yeah, no, GNOME uses that G settings thing, which is basically like the registry for Linux kind of thing.
yeah.
Have you asked on the GNOME mailing list?
No, I haven't tried.
You might check their archives. If you don't find the answer, try subscribing and asking.
Okay. All right, Steve, you ready to go?
I have a GNOME question.
Yeah.
So I'm getting frustrated. I think I'm about to retreat back to Windows on my desktop because I just can't get GNOME and NVIDIA to play nice together. So I have an NVIDIA graphic card that I want to use, and I'd like to use the GNOME desktop because I don't know, I don't like KDE that much. But I can get it to work on Ubuntu and on Fedora, but then when I sleep the system and try to wake it back up, it will not wake back up at all. It just black screen, and I don't even really have a good idea how to troubleshoot it because the only like even using like Control Alt F1 and 2 and those to get the different terminals, like that's
When you
also
say sleep, what do you mean?
sleep.
Hibernate or hibernate to RAM or what?
No, not to RAM. Just I think it's called S3 sleep. I might be wrong about that.
Well, there are 2 ways. You can hibernate to RAM where the machine uses enough power to keep the memory set, but the CPU basically stops counting clock steps. Or you can write memory onto the disk drive and then restart the machine where the kernel restarts and then reads its memory configuration footprint off of the swap space and then goes back in. If you're using hibernate to RAM, because all you're really doing is stopping the instruction counter, the CPU just goes into, no process mode until the switch is turned back on. If that behaves differently than hibernate, you've got a problem with reinitializing the hardware. Now, the hardware isn't getting set up properly. So I would try, if one is blowing up, try the other. See if you can get it to just hibernate to RAM and then restart. If that works and hibernate to disk doesn't, then you've got a problem initializing the hardware and you know where you're looking.
Okay. I'll give that a shot.
The other thing is just avoid GNOME. I mean, it's a complicated mess that's guaranteed to screw you up anyway.
Yeah, well, I really, I know Wayland. I really like Wayland. I just like I'm one of these people that can, screen tearing just really annoys me. And like, I like having consistent frame rates and stuff. I guess I just been playing computer games too long. But
yeah,
so I really like Wayland.
use
And this only
FPWM. It has
happens-
almost no overhead.
Yeah, this only happens under Wayland. It doesn't seem to affect X at all. Which is
Well, but then again, if you talk to the people at Wayland, there might be something somebody's seen before about initializing the graphics system.
Yeah. Yeah. And what is,
But again, if you're coming back from a write to disk and waking up, a common problem with that is that during the transition from command line to display driver, the display driver libraries may be doing something to reinitialize some of the hardware. And you find that, if you do a hibernate to disk, then because you're writing all the memory out and then just cutting the power to the entire motherboard, everything, when you restart, you reboot the kernel and then it reloads memory. If there's any step that was done to initialize or configure any of the hardware that you did in your normal life before hibernating, it's not going to be done again that way when you reload. And you can have a mismatch. If your normal approach is to boot the system into the command line and then start X to get your window manager up, at least you've got a chance to see what it's doing when it starts up. If you use a graphical login, you're fried because you can't see what's going on under the hood. All you get is the graphical system.
Still be able to hit.
But try just using hibernate to RAM if you need to recompile the kernel or something, and see if that works. If it does, then you know that the problem is that some of your graphics are, some hardware somewhere is not being reinitialized properly with the reboot and then just directly reloading the memory.
yeah, I'm pretty sure hibernate to RAM is what it does now, because it's certainly not doing a full
Okay.
when I turn it back on. It's like, it tries
Okay,
to.
then it just pops right back up. Okay, then you're doing a hibernate to RAM.
Right. And I feel like a hibernate disk, isn't that really slow? Like, I think I'd rather use Windows than deal with that, it sounds like. Because wouldn't that be super slow to load like 32 gigs of RAM
No, you should
from the
be,
disk?
if you use hibernate to RAM, then all the hardware is being left initialized and it just goes pop and it comes right back up.
Right.
But, GNOME is a complicated mess. So is KDE for that matter. There are other window managers that if you like high frame rates and you want simplicity, FEWM is one of them is the one I use. And it's a minimal window manager. It's not tiling. It just puts everything where it belongs. So you might find that gives you better frame rates, better throughput. It doesn't do as there aren't trays at the bottom and trays at the top and trays on the left and trays on the right and workspaces that pop up everywhere. Basically, you have a screen, you got multiple desktops, and you can start things in them, period. But at that point, that's really all you need. And avoiding all the other crap makes it a hell of a lot easier to get this running. Another cute approach is you can avoid GNOME and just use like TWM. You use the brain dead simplest window manager you can just once. Just go into your xinit.rc, comment out GNOME, and put in TWM. I mean, you're not going to use it day in and day out. Watch that startup. Open up an Xterm, a real standard Xterm, not anything else, and do hibernate to RAM. Just run it. And then restart the machine. And see if that restarts. If it does, then you know it's something in GNOME. And you can go over to the GNOME side and try and figure out what the hell is going on. Because right now, you don't know what layer is frying it.
Well, I know it's GNOME because KDE works.
Okay.
KDE works and GNOME on X works.
It's Wayland. It's GNOME on Wayland that fries.
Yeah, that's
But
specifically.
I would go back to
Xorg.
either Reddit
I want to go back
or
to Xorg. I like not having screen sharing. I don't want to go back to Xorg.
No, I'm saying
but if you go to the people that do GNOME and either Reddit or one of the other lists and say, hey, this is my problem. KDE doesn't fry me and GNOME does. Does anyone know of a problem with Hibernate and Wayland? And X11 does not fry me. So it's something about Wayland now on GNOME. And you'll find somebody else has dealt with it.
Yeah. Yeah, when I Googled it, what specifically like you're talking about, what they've come up with is some kind of suspend where it saves all of the VRAM, the video card RAM, the temp FS, and then it's supposed to reload that. And that worked under NixOS, but I'm kind of tired of using NixOS now, and I want to use something else. And so, but that worked under NixOS, saving all of the VRAM to the temp.
Why wouldn't they put it in swap with the rest of the memory?
I don't know. Well,
I guess if it's Hibernate to RAM, you don't care. I mean, that's not going to work if you do a Hibernate to disk. But for a Hibernate to RAM, yeah, that's safe enough.
Yeah.
But like I said, your problem is likely to be that when you're recovering from that Hibernate, they may be leaving some piece of hardware that isn't fully initialized. And that may just be a difference in the way Wayland's hooks for restarting are structured, and they may be different than X11's.
Yeah. And I'll keep Googling
I mean,
it.
if you want to.
I actually want to try the Hibernate to disk thing just to see how slow it is.
And see if that behaves differently.
Yeah, if it's not too slow, it might be okay.
Well, you're not going to use it every time. Just do it once to see what the hell it says. One of the interesting things about if you do the Hibernate to disk, well, do you use a graphical login or you log into the command line?
Graphical.
Okay, that was your first big fuck up.
Well, I don't know how to start.
Log into the goddamn command line.
Wayland command, or is it only?
Don't log in to the command line and then run startx. And what's important about that is when you start the machine up, don't run it in quiet mode. And you'll see all the little lines that everything prints out when it's frying itself, and you can see the error messages. If you start the whole thing up in graphical mode, then all you see is this pretty screen that doesn't tell you when the machine is screaming for help. If you can't figure out how to type startx, then do the simple thing. Just temporarily do it. Just for a short period of time while you're debugging this. Go into the system and have it start up at the command line, and you'll get just a non-graphical, you'll get a text window. And you'll log in with your username and password, and you'll type the word startx and hit return, or whatever the hell Wayland uses to start up. And at that point, the important thing is you can type whatever it is, 2 greater than &1, and pipe that to var temp, startup, .out, and hit return. And if there's an error message in it, you'll see it. Right now, all those errors are going out in the bit bucket. You can't find out what's wrong.
Wouldn't there be logs for like light DM or something?
Okay, and where the hell are they? Off the top of your head, everyone here, tell me where those logs are right now.
I would look in the journal.
And the answer is nobody effing knows, because nobody knows how anything is set up. Because every distribution, every person, everything sets it up differently. If you're stuck using systemd, it's all buried somewhere in the guts of journal CTL. And if you happen to know exactly the right magic for recovering it, maybe you'll see it. If you're lucky and you're still using syslog, then it probably is in varlog messages. If you have everything everywhere configured to go to varlog messages, but then everything's in varlog messages and you've got to discombobulate it from 85 other streams of errors. Unless you feel like using Splunk to mine the files, you're going to go nuts. This way, if you just do startx or whatever the Wayland startup is, redirect standard error to standard out and pipe it to one file. And you've got exactly one file that has exactly what happened when exactly this thing started up. Period. And now you can do less on that file, and you'll see if there's an error message.
Yeah, I found
As a matter of fact, if you can run the thing you can usually at least with X11, I'm sure Wayland is the same. You can start Wayland up in debug or verbose or something like that mode, where it prints out everything it's seeing and everything it's doing. And obviously, you're not going to do this every day of your life. But once, to figure out what the Hades is going on, just do that.
Yeah, I found the Wayland
At that
equivalent.
point,
Sorry,
you
I
can-
just put it in the chat.
But you know, I spent a lot of years supporting Unix for EDS and Hewlett Packard, and I learned the hard way. It's easier to see what's going on. 99.9% of the time, you'll ignore it, but you don't care. You're ignoring it. But the time that you need it, it'll be there. And that's why, to this day, I start my machines up at the command line and I type start X. It's one word. And boink, I get X11. And then if I want to see exactly what's going on, I can look at the X init RC, and I can run the thing in verbose mode. I can put whatever error messages I want out to the screen, whatever happens. It's a shell script. The xinit RC is a shell script. So you can actually have the individual commands, run them 2 greater than &1 and pipe them to something. Or you can actually run it in verbose, in the equivalent of a shell minus VX mode, where you can see every line and you can just print out the return value of every statement as it runs. And, you know, again, 99.99% of the time, you don't care because it all just works. But the one time it freaks, you got the log, and then you go, oh, that's where it blew up. And then you know exactly which command fried, and you know exactly what error message it emitted. And then you can put the error message on and say, gee, this is my startup script. This command gave me this funny error. Does anyone know what this means? And probably you'll get an answer. Or you can, you know, check the duck for it.
Okay, speaking of
But
getting,
the crummy thing.
if I could suggest, maybe we can suspend this if there are any more questions and move on to our main topic of the night. Otherwise, our speaker will be all upset that we've delayed him. Oh, wait a second. Stephen, who's been giving
I'm here.
excellent
I'm the one that's been wasting everyone's time.
However, there may be some participants in the audience who came specifically.
Who want to sleep tonight? Okay.
So let me turn it
Well,
over
anyway,
to Lembark from Workhorse Computing. Stephen's been a frequent speaker to us before. He did a fantastic talk about some command line stuff last month at our Wednesday meeting. And so tonight he's going to talk to us about
give you more crap about the same basic topic. So yeah, this is the whole BSDM subject. And this is about dealing with your command line. How many people here actually write shell scripts that are more complicated than, you know, 3 lines or anything?
20 or 25.
How many people here are alive? Everyone who's alive and awake say, hello, Steve.
Hello, Steve.
But that means they got to find
So
her
I got
on.
one person listening.
No, it means everybody else is muted. Like we.
It takes us a
Oh,
while to get our
unmute yourselves, people. Let's make this. Let's have fun. Okay, this isn't the 5th grade. I'm not going to rap your knuckles if someone asks a question. I don't have a little ruler. I'm not going to beat you up. Anyway.
This answers the question. Can we interrupt Steve during his talk for questions and comments?
Yes. If you have a question, feel free. But this is for case. This specific issue is partly about dealing with arguments to your programs, and partly just some general introduction to dealing with variables a bit more in Bash. So command lines, when you put them in, there are a lot of ways over time that people have had for processing the command lines. I mean, going back to Unix on PDPs in the 1970s. Most of the approaches everyone had were terrible. And everyone was tearing their hair out. And finally, someone came up with a thing called getopt. And there was getopt. Oops, I screwed up. That should be getopt 3. Getopt is the C function that takes your argv and hands back a variable sized array of all the answers that you care about. So Bash uses getopt from the command line. I'll look at getopt, the while loops built in the Bash cases, which are how you handle the individual statements. Or Bash has arrays. They're numerically indexed, the standard ones we're used to. There's associative, dictionaries, maps, hashes, whatever you want to call them, and how to set up functions, the basics of a function in Bash. And, you know, one more BSDM joke, title up nicely. So Bash stores arguments. Has anyone ever played with the command line in Bash?
Yep.
No. Okay. Okay. So there's one person who has. The rest of you, I hope are awake. So the notion is we got options. And originally, all of the options were short. They were a dash and a letter, or a bunch of letters, or a bunch of letters and arguments. You never really knew. And then you have double dashes. Some of the switches on the command line may have arguments, some might not. And then you're stuck dealing with them wherever they're typed. So if you look at here is an executable called foo, blech is blort, bim. Is my path an argument to it, or is it an argument to the program? And then you have dbam and v1 and x. There's no guarantee that people type any of this in any particular order. There's no guarantee that if blort is typed, it's not all in uppercase by mistake because someone misunderstood you. There's all kinds of ways people can screw this up. So the basic idea of the options is they're the things with the dashes. Anything with dashes in front of it is a switch to the program. Then we have arguments. Now, blort has got an equal sign, so it's got to be the argument to blech. Minus D has bam as an argument, we think. Minus V1, yeah, one's probably, but notice there's no space. So it's up to you to know whether it's minus V with a 1 argument or it's the minus V1 switch. No idea. And my path might be the argument to BIM and it might not. Guessing the program arguments might be my path and BAM and 1. Then again, they might not. You can see where every scheme that people have for dealing with command lines is messy. Getopt was the first version of this that ever worked. It takes in a list of possible switches. It takes in some metadata that tells you whether the switches have arguments, whether they're Boolean, whether you say the same switch more than once, it ups a number, like you have minus V. Everyone's here seen minus V is verbose. Minus VV is even more verbose. And minus VVV, or minus V minus V minus V is really verbose. And so it doesn't set the V switch 3 times. It says, oh, V is incremental as opposed to just Boolean. So all that metadata is about knowing how to deal with each of the individual switches and what it's supposed to have so that you can actually compile an input line into real arguments. And the whole point of that is I've got to take all the switches and all the options to the program out, because what's left are the actual program arguments, like an input path. So if you do a DD, IF, OF something, input file, output file, there might be an argument at the end of it, or tar minus something something, and you give it a directory name. You'd have to know the directory is being processed by the program as a whole. It's not an option that changes the way the program's running. So one thing that getopt long added was instead of having just a dash and a letter, there were double dashes with long names. And the great thing about that is you can say foo equals bar. So you've got something that says, oh, I know that bar is an argument to foo. End of story. There's no guessing. You don't have to figure it out. You know. Every language since then, and that was in the 80s, has used some kind of getopt long. Perl calls it getopt long. Bash just uses getopt that handles long switches. Python's got something similar. Every language today uses something getopt-ish and gives you the same basic life cycle for these. Now, bash stores the arguments in array. Whatever order they were typed is what order you get them in. So it just takes the command line and breaks it apart on white spaces respecting quotes. Now, a quick note when we go into this, there's a $splat and a $@ sign. If you don't put them inside of double quotes, they behave identically. They give you a string of everything that was typed. If you quote things, $splat, there's a variable called IFS that is it's the variable you set that tells bash how to split arguments apart. And it normally starts out as white space. It's a space followed by a tab followed by a new line. And what it'll do is take the first character of that IFS variable and it'll paste all the arguments together with that. So that was what bash thought you typed in. $@ is kind of neat. It gives you all of the words separated. So that allows you to pass the arguments into a function that processes them, keeping each word separate so the function can do what it needs to. Does that distinction make sense? Everyone with a heartbeat, just say hello.
Still thinking about it, but I think it does.
Yes, it makes sense.
So, well, if you look about it, $splat inside of quotes is how you print out the argument list. And I'll show you an example of that with say you want to create something, a function that prints out log messages. It'll take all of its arguments and prefix it with a date and a program name and a tab and then $splat. So it just takes all its arguments and just packs them together inside of the one long string. $@ sign is how you iterate down the arguments and see what each one of them look like. And it's what we'll be using to process the command line. Now, an interesting thing.
Why am I thinking of that as exactly the reverse? Because you're saying, go back to that previous slide.
$splat
Okay.
takes all of the arguments and packs them together with a space in between into one long string.
No.
$@ sign, $splat produces a single scalar string. $@ produces an array.
Okay, I misunderstood you then. I thought it was exactly the opposite. Okay.
In Perl speak, $splat is joined with a space at underscore.
Okay.
$@ is just a flat array of things. It's an array of separate things by space, broken apart by spaces.
Okay.
So you can think of $splat as pre-parsing and $@ as post-parsing from the command line point of view.
All right.
Did that help the way I said it?
Uh-huh.
Okay. So an interesting thing is there $splat and $@ there's one of those in the main portion of your program, and then every subroutine, every time you call it, has its own local $splat and $at. So everywhere you call it, because it's localized, you have, if you're going to write a function that processes the command line, you'll have to pass it as $at. Because then the subroutine gets each of the arguments by itself. You'll see how that works in a minute. But a lot of people screw that up. You forget to pass the arguments in and you drive yourself crazy. That's why I put this up front. So there is a function, it's a shell function called getopt. It is different than the built-in function getopt, plural, that is in bash. The getopt is much more simplistic, and I'm going to ignore it from now on. Getopt, the shell command, is what you want to use. So again, there are two types of arguments. If you look here, you'll see a -v1, -vbam, -x. These are short. They're a single letter that might or might not have an argument. The argument might be glommed up against the variable, or excuse me, against the option, or it might not. So these two lines are identical. Oops, except for the typo -x I left off. Minus VDX1 BAM is the same thing. Whatever of these needs an argument, it will consume the number 1. The next one that needs an argument will consume the BAM. Can anyone here imagine that that is confusing?
Yeah.
Because if you don't know whether D or X takes an argument, you don't know which one of those is going to get 1 and which one's going to get BAM. So the old single letter dash approach is horrid. Don't use it. Now, the long arguments are a much better way to design it. You can say Blech equals board or Blech blort. If you're writing shell code and you invariably use long options with equal signs, whoever has to maintain the code, and that poor slob may be you, is always going to be happier. Because the long options, they give you some idea what they mean. You know, if you give a minus G7, what the hell is G for? If it's, you know, minus go to hell 7 and you know what lever of hell you're going to, bang, you're done with it. So you can't stack them. You don't have minus Blech, minus foo, and then blort, something. It's just minus Blech equals blort. They have to be attached. This is a much better way of passing things when you write code, even at the command line. It makes more sense. Use long arguments is the first thing I can tell you. Always write stuff so that it takes long arguments for anything that's non-trivial. The short options can be kind of nice if you've got debug or verbose, you know, switches that are, you know, binary. Minus D for debug, V for verbose is a classic, or minus H for help. I should have included that. Minus help and minus H both get you the help message, fine. But if you're going to the minute you start putting arguments into short options, it just gets too hard to parse. So let's look at the first way of cleaning things up. What you can do is pass everything you're doing to getopt. You give it a list of short options with the minus O. You give it a list of long options, and you can have minus short, minus long, but they don't fit on the screen. And then double dashes in shell land say, these are the end of your options. Whatever follows are the arguments to the program. So what this line is saying is that getopt is being told minus O minus L with its arguments, and everything else are the arguments to the program that's running. Don't fiddle with them. Now that $@ is whatever the person typed at the command line. So set, the cute thing is the set function built into bash sets a variable. By putting set --, you're basically saying set the variable that has no name. And the unnamed variable is the arguments. So this jam loads $splat $@ with whatever the result of calling getopt is. By evaling that, I get this is a long list of whatever, and that's put into a new set of arguments. So what getopt does is take whatever mess somebody typed in for you, and it puts it in a sane order for processing and pukes if there are any errors. So this $# separates the getopt switches from your command line. Does that make sense?
Yeah.
Because you might have a minus O in your program, and getopt's got to know which is which. So that $# is an important thing. It works in Perl. It works in, I think, Python too, where if you're passing arguments to Perl that are part of the program that's running, you can put a $# and Perl knows not to parse those. It just leaves them on the argument stack. Set minus minus is how you reestablish the arguments to the program. This is an undocumented feature of bash that you will find if you read the getopt documentation carefully. And then an eval is a bash built-in, and this Perl, Python, everything else has got one that says, take this text, interpolate all the text, and then reevaluate it one more time as a piece of code and keep going. So it allows you to recompile. So whatever the result of getopt is, you're going to evaluate that text by setting your arguments to whatever that is. So now what's that? So what you start getting, you get this mess will be sorted. So now we can look at this and we can say, oh, Bletch is blort. BIM has no arguments. B takes a BAM argument, V1 minus X. Oh, and my path is the one argument to my program separated by a double dash. What's important about this is if you walk down this, every single one of the options is separated out. If someone gave you minus VX1, you're going to get minus V1 and an X. So all of the options and their arguments are paired. Any option that doesn't take arguments has a dash following it. So, you know, minus X doesn't have arguments, so the next thing there is a dash. Minus D, bam, you know that if you're seeing a minus D, there's an argument. You know that if you're seeing minus minus BIM, the next thing after it has a minus because BIM doesn't take arguments. Now it's really easy to walk down these one at a time and say, oh, I know what comes next. I saw a Bletch. I'd better see an argument. The very great thing is the minus minus is how you separate out switches, which control the program running, from arguments that the program consumes. Did that make sense the way I said it?
Ooh, say that again, please.
If you look on the left side of this, there's all the switches that control how the program behaves. This might be verbose. This might be a working directory. Whatever these are consumed by the program to tell you how it operates. This is the argument to it. Think of tar. If you give it a tar and you want it to compress, you do a minus, I think, X, right? Or minus G or whatever.
Mm-hmm.
Tar minus G foobar. Minus G says, I'm telling tar how to behave. So it's going to consume all of this stuff before it knows what to do with that, because these are the options that control the program. This is the input that the program consumes. Do you see the distinction I'm making?
Yeah, yeah.
Your command, I'll show you in a minute, but your command line loop is going to eat all of this, strip off the minus minus, and leave this stuff, because that's the main part of what your program operates on. And I've got a good example of this. If we get through all of this, I've got an example of something I wrote today that compiles a copy of Perl and uses it, so I'll show you what it means.
Where your cursor just was, the double dash right in front of my path.
Right.
Is it my eyes, or is that in red instead of in black?
Yeah, it's in red because I was talking about it.
Okay, all right. Just
Back here it was in black because I wasn't talking about it.
Gotcha. Cool.
It's called highlighting.
What a concept. Damn.
So your command line loop is going to walk up this until it sees the double dash. Now, if the first thing you see is a double dash, there are no switches. This is what makes it so easy to process, because you're going to walk down this. The fact that getopt didn't puke means that all these are valid. So if you can consume all of these and then stop at the minus minus, your life is good, because whatever comes after it isn't your options processor. It's stuff you're actually consuming. So one thing we can do, just to make this line a little bit readable, I can say, here are my short options. Now, you see this colon, that says that this takes an argument and this takes an argument. So D:(V:(X) says I have 2 short switches that take arguments, and X that does not. The long arguments say that I have, oops, I screwed up. Those minuses shouldn't have been there. Downside of writing this on coffee. So you got Blort and Bim. I'll clean this up and give it back to Gary. Blort takes an argument and Bim takes no argument. So if you see Bim, you know there's nothing following it. And there's versions of this for optional arguments and other things. You can say that the argument has to be an integer. You can say it has to be whatever. For the moment, it's just there. Now, if you had to read this and look at it, my arguments are whatever I get back, and I can set from the arguments. It doesn't look that different, besides that short and long are maybe a little bit more descriptive, but where it gets, oops, I apologize, wrong. Oh, come on. Oh, here we go. So the cute thing here is by storing these arguments, it makes it much easier to have a better error message. Because I can say if this comes out, if those arguments match the word unrecognized, this is a regular expression match in Bash, then I can print out a usage message, call my usage function and say, you gave me bad options. These are the ones you gave me. And this message will say, bad list of options, you know, minus foo unrecognized, and it'll tell you what the bad option was. By storing this and then outputting it, I can give people a usable, readable error message. Does that make sense?
Yes.
Yeah.
Okay. This saves a lot of work because now you don't have to walk down each of these and say, do I recognize it? Oh, issue an error message for what I didn't recognize. It's all done for you. Your error message for bad command line options is just print out what you got back if it says unrecognized. And there are a couple of other things it can give you. If you say it has to be an integer and the argument to it's bad, there are a few things you can actually search for here, but this is easy to see. Now, if I get past this, I set the arguments and keep going. So now I've got these arguments set. What do I do with them? So I can iterate my new $@ sign, which now is in a processable order. When I see the minus in it, I know to stop. I've dealt with the switches. I'm now down into the program arguments. So an example of that, I would, if I eval the set, the while colon semicolon, has anyone seen that before?
No.
While true.
Yeah, it's the moral equivalent, but instead of re-evaluating true and go, remember, Bash is not compiled. It is a translator. Perl and Python are compiled languages. They don't compile to assembly, they compile to bytecode. But Bash actually has to figure out what each line means every time it sees the line. So the while colon semicolon is a speed up. It says, don't evaluate any further, you know to keep going. It's the equivalent of C of a for semi-semi. A for within, a for loop in C with an empty set of arguments. In Reiku, there's a function called loop that takes no argument. The only argument it takes is the closure of what it's going to run.
I read that as
so
forever.
Yeah, that's while forever without bothering to check. It just saves time. It also tells the person reading this, oh, this is going to go forever unless you do something to break out of it. So it's a quick warning. If you see that, expect a break somewhere in the code or an exit or something. So what's wrong? Oh, I thought there might have actually been a question. Sorry. So case $1, $1, $2, $3 are the elements of $@. So these are the arguments in order. And again, these were reestablished when I did this set minus minus. So $1 is the first thing that getopt sorted out and put in the line. And if $1, if it's a double dash, then I shift it off because I'm not going to use it anymore. And I break because the program arguments are all that's left. I'm done processing options. Did that make sense?
Yes.
Okay. Well, then Bletch. Now, one thing I know about Bletch does take an argument. So if I see Bletch here in $1, guess, if you had to, where the argument to Bletch would be. How about $2?
Oh. Mhm.
Now, I'm going to shift something off the stack because I have to consume two things. And I do the rest of this for minus minus help, minus H, minus X, minus D. Anything that I know takes an argument, I take $2, shift it. And then every time I go through this loop, I have to shift at least one thing off. Do you see why?
Yes.
So every time through this, I'm consuming the first item. If the item has an argument, I may have to consume two things. So there's an extra shift in here. But otherwise, there's a shift.
Oh, okay.
And this will just chew through. It'll say, oh, is the first one Bletch? Fine. I know I'm processing Bletch. Its argument is whatever follows it on the stack. Shift that off and then shift off the Bletch. So here's two shifts if I have an argument. Dash doesn't have any arguments, so there's no extra shift. And this will chew through. If you have something like minus H, it might just print the usage message, which doesn't exit. So it might just say usage and double semi, because it doesn't need to do anything else. It's going to exit right after that. And again, if we can get through this, I'll show you something I had to write today. I've written this 14 times, and every time I write it before now, I was working for a place where I couldn't take any of the code with me. So I've gotten very good at rewriting this. Now, okay, the bad thing about this, if you look at it, Bletch, verbose, debug, that Bletch equal $2 means that I've got a global variable named Bletch. Well, that's easy to process. It's easy to set in here, but now I'm starting to get global variables and people write something else. And if this were verbose, maybe someone else sets verbose to something else. And now I don't know how it's set. It's just easy to step on yourself. So another way to look at this is I can use a subroutine to compartmentalize the variable space. There's a typeset function. It's built into Bash. Another synonym for it is declare. And typeset minus R says make this read only, so that if you accidentally step on it, you know. So typeset minus R short equal this. And one thing I learned, by the way, because you've always got the variables and the arguments in Bash can't have any white space. You can't put short space equals because it'll confuse it. So a neat way to make your code a little bit more readable is instead of lining up the variables and having this jagged line of equal signs with stuff on either side, if you line up the equal signs, it's a lot easier to walk down it and see what the variable names and the stuff on the right side are. So, and again, I screwed this up here. I'll fix that before I upload a real copy to Gary. But the short and long, if I accidentally try to modify them, I will get a runtime error. So then I can say local argv equals this, and the rest of this. All of these, they're typeset. Anything I declare with local only has meaning inside of this function. Did that make sense?
Yeah.
Hello?
Yeah.
Have I put everyone to sleep this quickly?
No, you haven't.
That's
Okay.
the process, what you said.
But It's like lexical variables in Perl, my variables. Python finally has the same thing. You don't have to have everything be global. You can define a variable as only living inside a function. So that's what we've done here. The local says here is a variable that is local to my subroutine. Typeset does the same thing. It localizes a value to the context in which that variable is declared. R marks them as read-only, and that just saves you from typos. If you know that if you accidentally assign something, it just saves you. And again, $@ that should have been $splat too. Sorry. They're always local to whatever context they're used in, so you never have to worry. Now, everyone knows what this means, right? Oh, come on, people.
No, I don't know.
This is the motto of Perl. There's more than one way to do it.
Oh,
Tim Twitty.
Obtuse to the
There's always more than one way to do something. So I can have this function command line here, and now I want to export these variables. If I make everything local to the command line function, I really haven't, it's not very useful because I got to get something out of it. I got to know what somebody typed. So one way to do that is I can typeset the variables in the global space and then assign them down here. If you do a typeset -L, that says that anything stored in this variable will be lowercased. And if you have, let's say, Bletch is true or false, how many ways are there to mistype true? Caps lock. Is true capital T true, or is it lowercase t true, or is it true typoed, or is it true all uppercase, or did I accidentally hit the shift key at the end of it? Who knows? If I declare a variable lowercase, all I will ever see is the lowercase version of it. For things that are effectively enums, this makes life so much easier because people can't type it wrong. Yeah, that makes sense.
Yep.
The other cute thing about this is if I typeset it up here, anyone walking up to this knows that there's a global variable named Bletch. And they can look at that should have had spaces around it. I was thinking of Perl. God, I really typoed a lot of this. So Bletch equal to, I can look for Bletch equal sign and find it and be done. I know that I'm looking for it. If there are 8 of these at the top, I know what in my code I'm looking for. Now, the trick there, another way to do this is I can just hand everything back. And I can say my arguments are execute the command line, and whatever it hands back, those are my things. The problem there is if you push these back as a list, you have to know what order they're in. And argv of 1 is this, and argv of 2 is that, and it becomes kind of messy accessing it. This works, people used it for a long time, but there's a better way than having to memorize the order. You can have an associative array, and they call them map, call it a dictionary, call it a hash. There's different names in every language for these, but it's an array indexed by name, by string, rather than by number. So instead of saying blort equal $1 or 2, I can say argv of blort. Now what I've done is I've declared a variable that has blort as a key, and I'm setting it to a value. Bingo. Now I can look at this, and I've got all of them in one place. There aren't 15 variables scattered all over, and I can tell what they mean. So if verbose is turned on, I can say argv of verbose equals 1. I just arbitrarily set it to 1. Otherwise, I set it to an argument. So now I do this. I can do a typeset -A of argv, And it looks nice because people look at this and they say, oh, argv is an empty array. I wonder what you're filling it with. And it's, you know, pick your name for this, arguments, program args, whatever. And then I go through somebody, again, if I define this at the top, if I don't, simply assigning it is enough to create it as global. And simply assigning it the first time with the square braces and a word inside it is all it takes to declare the global variable and keep going. So it depends on if you don't like that typeset, if it gets confusing keeping things, you can do it this way also. But now further down, someone can say if argv is verbose, I can ask, am I running verbosely? It's a bit more text down here when you're testing it, but it means you only have to keep track of one variable, not 45. And it means that adding something new doesn't drive you crazy. You don't have to find the variable for it. Another way to do it is, now I've done this, but I've got another problem. Oops, nobody's asked this yet, but what do I do with what's left in $at? Those are the actual program arguments. The easiest thing to do is hand them back as a list. If I do that, I can create a read-only variable called command args that's whatever I get from reading the command line. My argvs, or call them options, ops maybe, is whatever had dashes on it. And these are all the arguments left after processing them. It's whatever was after that double dash. So if I'm writing something that does a tar and I want to pass switches to it, I've read all the switches, and now here's the arguments that I'm actually processing. Does this make sense?
Yep.
Okay, so at least I haven't killed all you. Now, another thing is, and this is something I put in the top of everything I write, I call base 0 and dir 0. I break up the program name. The neat thing about that is when getopt gives you the nastygram for unknown switch, if you give it a -n and a word, that will be, it will tell you the name of the program. So it says invalid arguments to whatever its -n argument is. So the cute thing here is I can, by putting this base name in, I can get a more reasonable error so that if this shell script is called from another shell script, 14 levels deep into my operating, it will tell me which of the pieces of code actually issued the error message. And this can go a long way, especially if you've got something running in the middle of the night and all of your logs are centralized with journalctl or syslog. You'll get the actual name of the running program that complained about it, which makes it a lot easier. Hey, who here has a --blech argument? You got to research it and find it, and you go crazy. And what if 3 people have got it? Now you're all fighting over whose blech was the one that blew up. This way we know exactly which program died. And that's as far as I got. So the basic things you can do, and this is completely reusable. If you have something that does command args equal command line of this, one cute thing is the way arrays work in Bash. If you access an array variable without supplying it an offset, you're accessing the 0 entry, the first one, which makes it really easy to ask the question, do I have any arguments? I don't have to go, curly brace this in a 0. If this is empty, you forgot to give me any arguments. Oops. So I can call fatal, tell you no arguments. You blew it. Otherwise, maybe I validate a source file, I do whatever, and if my argv are verbose, then echo verbosely something. This is a general structure that'll work for anything you're ever going to write in Bash.
Okay, I got it. I got the first part, but I don't necessarily understand this verbose part. What are we doing here?
Well, basically, if I store all my switches, if I store everything that you pass me, maybe I should have called this ops. I'll rename it to that. If these are the options that I processed on the command line and you passed in minus verbose, let's just say, or minus V is verbose. I set argv of verbose in here. It's global. So now when I get, and someone wants to know whether or not verbose was set on the command line, they look in the argv and they say, was verbose set? If verbose is not empty, then I echo something, or I say whatever I'm going to say if I'm running in verbose mode. My command line arguments, the things I'm consuming, are handed back by this function. All of its side effects that define how the program is going to run are left in argv.
Okay. Yeah.
And that separates it out pretty nicely. You know that the command line arguments are there, and it's read-only. You can't screw them up.
Yeah.
And so I can look at command args of 0, command args of 1, whatever, or I can walk down them and say, okay, now that you've given them to me, what do they mean? But if I want to process one of my initial switches, that's in the argv hash, and I look up verbose in there, and if it's not empty, then I do this. Or I know what you gave me as the argument to that switch. And if you want to see more about that one, man of bash tells you everything there is to know about bash. Getopt is a separate program. Again, there is a getopt, plural, that's in bash that does not do nearly as much work as this does, and it is not worth using. Any system that has bash on it will have getopt at the command line. Just use the getopt command line utility. It does a much better job. And if you do a man 3 of getopt, that's the C version of this that goes back to the late 80s, I think is when that came in. I'm trying to remember when I started using double dashes, but it was around the 80s. It's been there a while. But the getopt in C is where long options were first introduced. And you can see how it's supposed to work. Late 80s, early 90s, it was around then. And that is it. What I can show you is an example of doing this. Bingo. Is
Font.
Too small.
Bump it about 4 times.
Is this legible for people, or do I need to raise the font size?
Bigger. 4 times.
Okay.
If you were running GNOME, you just do Control Plus.
Yeah. No. Well, but that doesn't work in my editor. Hang on. It does work at the shell level, however.
True.
Why don't you use a good editor?
This is the one I like. The nice thing about Vile has a lot of advantages.
Oh, it's a good editor.
But the main thing is, unlike Vim, it actually looks like VI. But you'll see what I do here. I start the program and I typeset base 1 and dir 1. One thing I'll do in a lot of programs, let me do that here. A lot of times it's handy to know what directory you're executing from. So I'll do a typeset -r bin d equal to cd $dir0 pwd -l for serving the symlinks.
Is there a chance you
And-
can make that one size larger?
No, I'm just going to read it here.
Another thing you can do is if you have
So
the
here,
option button above that, not Stephen, but the rest of you. If you have the view option button, you click on that, there's the option of fit to window or original size. If you go to original size, it'll be hard to find his cursor on the screen, but you will get nice readable font.
okay. Oh,
Boy,
is this large? This is, well, the only point is, if you CD to this directory, you know that the point where you start, this is a valid path because you're running it. If you do a PWD, it gives you an absolute path. So this is a quick and dirty way of converting whatever path somebody used to start the program, .. /foo/bar, into just a single absolute path. The -L preserves any symlinks. But then again, the date that I start at, my log file, this regular expression are all read-only things that are globals. What I generally do with globals like this is I'll make them read-only so I don't accidentally step on them in the code.
Stephen?
Yeah.
You might follow up on that request, and can you make that any larger? Because it's hard to follow.
This is the large, well, let's see. How about that?
that helped.
Keep going.
Okay. Shit. How blind are you people? How's
Sure.
that?
That's better.
That'll work.
Lee's pretty
Okay.
far.
So an example of using $splat. I call the log message function. It puts a new line. It tells seconds is a variable that tells me how long the current executable has been running. So it just gives me a quick idea of how long it's taken to do things. Base 0 gives me the name if there's a bunch of these running. A tab, and then $splat just nails the entire argument list together with spaces and splatters it out. 1 greater than %2 puts it to standard error. Fatal logs whatever you told me with fatal in front of it and then does an exit. This is execute, which runs something. My main use of this is running shell code. If I assemble a line of shell, this will print it out so I can see it, validate. If I pass this in with $1, if I pass a command and a bunch of arguments to it, this will verify that at least the first thing in the string is executable. So if I botch a command line statement with a non-existent file, I'll find out specifically why it couldn't run. It gives me a bit more detailed error messages when I'm trying to find out what blew up at 2 in the morning. Eval of $splat takes all of the arguments, gloms them together, and runs them as if they were code. If they return non-zero, I tell you what the $1 was. I don't do the entire line because you just saw it a minute ago, and then I tell you its exit status because that's all you really know. Whatever it emitted is going to come out. Now, another approach to that is you take this and you can say log message of eval of this, and that will print all of the stuff out. But it just gets to be a lot of, this is a good place if you had a verbose switch. You could say something like, you know, if I'm running verbosely, log a message with the output of this, otherwise don't bother. Usage is just, you know, cat some things with an end. Here's my command line processor. So I've got my longs, which don't have double dashes on them. I got to go through and clean up that presentation. So I have help and recycle. Help, guess what that does? Recycle saves you from recompiling the copy of Perl. It's if you're doing the installation phase and it blows up, you can reinstall things. V&H or verbose and the short version of help. So again, I do the set. This is exactly what you saw before. And then if I always know there's going to be a double dash somewhere. It may be the first thing if someone didn't give me any command line switches. Help and -H mean dump the usage. That's going to break out of this infinite loop because if you look up here, the usage does an exit. So this gets me out of running the loop forever because the program terminates. Otherwise, I've consumed one thing off the stack. Now, if one of these took an argument, I know I'm consuming two things off the stack because of its argument. Another way to do this is if you have an optional argument, by the way, you can say if $2 starts with a dash, then there is no argument to this. One of the great things about the way getopt orders things is you know that if there's an optional argument, the next thing, $2, is going to begin with a dash, period. Even if it's the first dash of double dash, it's going to begin with a dash. Anything that does not have an argument will have a dash as $2. So it's easy to tell with optional arguments, because you can say if $2 begins with a dash, skip it, otherwise save the argument, or use a default or something. So now I've shifted all of this stuff off. I've consumed everything up to here and gotten rid of it. The way this program works, you have to give it an input. So you can run it, or you can optionally give it an input. You can give it the name of a tarball, or you can give it the name of a directory that's a Git repository, or you can give it the output of the previous execution untarring the tarball. This is one of the program arguments. --recycle is an option. The options get consumed and they control how the program deals with its own arguments. So here's a case where I've got an option and an argument. Does that make sense?
Yes, but are you expecting people to put 2 dashes between those?
No, that's the beauty of it.
Okay.
You don't put 2 dashes there, but getopt does. So what I'm going to get back, the character string I get back from running getopt, even if somebody puts base0 path to Perl star space --recycle, the string I'm going to get back is --recycle space dash dash path to Perl, whatever the shell expansion of path to Perl star is. And that might be Perl dash 1, 2, 3, 4, 5. Whatever it is, the shell does this expansion, and then that becomes the argument to my program. But they don't have to type double dashes. Getopt inserts it when it runs here, so that I get a double dash, and I know when the end of my switches are. I can see the last option because it ends with the double dash. If you type no options, so if someone ran the program this way, if someone ran the program with just its name, which assumes the current directory, all I'm going to get back from calling getopt is dash dash. If someone runs it this way, I'm going to get dash dash space path to tarball.tar.gz. Does that make sense?
Yep.
Getopt inserts the dash dash for me so that I always know when the switches end.
Yeah.
And because it's dash dash, I always know that if any of my switches, any option, has an optional argument, if the next thing isn't a dash, then I know that there was an argument. If the next thing is a dash, then I know that there won't be a dash following me, and I have to consume that as the argument. If the argument takes a leading dash, then getopt puts it in quotes for me so that I know there's not a dash. I can tell the difference between switch arguments that have dashes and program options that have dashes. It makes it much, much easier because now the only thing it ever takes to process them is this. I have a case, and each of my options is one example in the case. And if there's a short and a long that do the same thing, you do it this way. That's it. This is all of the logic it takes to this while loop will deal with the output of getopt every time. So it's much, much simpler. And you know that if somebody if they typoed one of the options, if they typed recycle without the E on the end of it, they're going to get a nasty gram up here. So I only have to process the options that are valid, because invalid options don't get this far. They get removed up here.
But how does it know if it's missing an argument? Like how does it know if it's missing?
If the notation, well, here, where was, here. Oops. Hang on, let me get this back on the screen and I will show you. The metadata for getopt tells you whether the options are optional. So here, man getopt. The opt string and the parameters, which are parses parameters in the synopsis. So along character options, they specify once. You separate them with commas. Each option name in long ops may be followed by 1 colon to indicate it has a required argument, or by 2 colons to indicate it's optional. And here's where that name that gets used in the error messages is. And the short options are 1 character options. And again, they can be followed by 1 colon or 2 colons. And you can use a plus or a minus to change some things. But in general, another thing you can do is, because bash is the default, but CSH has a different format where you can use minus and plus. And they mean if you turn something off, you put a plus in front of it. So CSH and TCSH have slightly different semantics for the way you supply the program options. Yeah, unquoted, never ever use it, because white space, anything in the actual switches that turns out to be important to the shell is going to fry your ability to run it. But there's now this thing uses the actual getopt C library. So what it does under the hood is classic getopt 3. So if you do a man 3 getopt, you will see what all the different ways it can do things are. So all this is really doing is it's a wrapper around the C function that passes things in. If this thing pukes on its own parameters, if you give it 3 colons, you're going to get an exit 2. If it blows up and testing, if you're in test mode, it'll exit with a 4. But in general, in your own testing, you're going to get rid of this. In the modern world, you don't usually get out of memory unless you're running on a Raspberry Pi, and even those have gigabytes today. So normally what you're going to get is an error 1, which means that someone put a bad switch in. There's POSIXly correct, there's getopt, and that you can set that in the environment. But this is basically, you can put this with the parameters, or you can not put it with the parameters. The double dash is unnecessary because it does a good enough job of figuring out what's what. The only time you need a double dash is like I did here. Because, okay, if this is processing, I say it right, because your stuff probably has dashes and double dashes in it, this double dash separates out the switches that are being supplied to getopt that control how it works, and the arguments to getopt, which is what it's parsing. Does that distinction make sense? So the -O short and the -L long are the metadata that it uses to figure out what these mean. That double dash separates out the information you're supplying to getopt with the input that it's processing as work. Does that explanation help?
Yeah.
I had a question about, so
And
you,
the same,
you put the dash in with
Oh.
base 0 there, but then in your error message down below, you're putting base 0 again. Is that like duplicating it?
well, because you may, yes, belt and suspenders. The other thing is, you can have a problem if this line is long. It can get split into multiple lines in a log file. And this way I can always search for bogus space program name and find it where this might have wrapped onto a new line and there might be, it might not be together. So yeah, I could have left this out. I could have called this bogus command line. There's a lot of things I do that are belt and suspenders because I've been there at 4 in the morning banging my head against log files that didn't have enough data in them. But you're correct. That one is actually extraneous. And so now, if you look at this, I've chewed through $@. I found the double dash and shifted it off. So now, this $1, if you look at this point in the code, the $1 here is going to be the path to a tarball or a directory, a repo, or a previous untar directory. If someone runs it this way, the return of getopt will be -- as a single string and nothing else. If someone runs it this way or that way or that way, I'm going to get -- space, whatever they typed, path to get repo. And I'll know that there are no more switches. So that loop is going to run exactly once and consume the double dash. If someone runs it this way, they're going to have the program $1 is going to be recycle. It's going to be followed by -- and nothing. And in this case, I'm going to get recycle space -- space, and the next argument is path to Perl. And when I set that, I'm going to get recycle is $1, -- is $2, and the path, whatever this extrapolates to, is going to be $3. So my loop is going to read through this. It's going to set recycle to true, shift one thing off. It's going to go back through a second time. It's going to see -- It's going to shift one thing off and stop processing this part of life. And $1 is going to be that path to Perl. So here I've consumed recycle. I go through the loop again. I see, I got a -- I shift it off and I stop. I'm done. Now, if somebody typed an argument to the program, it's in $1 because I've chewed through that much of $@. So I can say if it's a directory, I know that my build directory is that one, and I'm going to build there. Otherwise, if recycle is true, you screwed up because I can't recycle a non-existent directory. So I puke. Otherwise, if it exists, it's a tarball. and I'll validate the tarball later. Otherwise, you gave me a non-existent tarball, which doesn't do me much good. Otherwise, you didn't tell me anything at all, so I'm going to assume for the moment that wherever we're working is a distro directory and keep going. When I'm done with this, and again, you can see the approach I used here was just defining some global variables because there's only one of them. It doesn't really matter much. So the build directory or the tarball, I can define one of three variables here. I might have set recycle. I might have set the build directory. I might have set the tarball. If I'm alive, now I'm going to go through, I'm going to validate my runtime environment. So I'm going to validate that curl and make dir exist in my path. I'm going to check the build directory. If there is a build directory, I'm going to validate that it exists. The reason I do this for loop, by the way, I say for I in this, you'll see this all over the code. I use the single letters I, J, K, X, Y, Z, A, B, C as throwaway variables. Technically, they're global, but I always overwrite them because I never use them past the length of a single loop. So even in the same subroutine, I'll use I everywhere. It's there to be overwritten. But the point is then all of my tests are on $I, so I can cut and paste them. I don't have to put build D here and something PWD here and something else. I just say, for I in build directory, if it exists, if it's executable, peachy. Those are the two things I need to validate about it. Actually, I should validate if it's writable there. And I'm done. Now, if I'm recycling it, I don't need to write to it, so I don't validate that yet. If the tarball is non-empty, I call extract tarball, which is going to puke if it can't get the tarball extracted. Otherwise, the current directory has to be writable or fried. Then I check my working directory. I make sure that that's writable. And then if the build directory looks like curl, I check, does it have a git subdirectory? If it does, I can call git branch and make sure that I've got a versioned branch checked out, because that's how I'm going to know what version I'm building, because that's how I figure out what directory to put this in. Otherwise, if the build directory has a version in it, then it came from extracting a tarball. And the directory name is going to be curl dash 5.40.0 something. It's going to be the tarball name with .tar.gz stripped off of it. So I'm going to get that. Then I know what the Perl version is.
Executable check up above.
What is?
You might want to add.
Yeah, I just hacked this today. I'm not done with it yet. I'm in the middle of making this thing work. But yes, there's a few other shell things I'll probably put in here. Git, make, just about anything shell-ish, I'll eventually put up in that loop, and I'll make sure that they exist. And the only reason for doing that, the code's going to blow up just as well, because if you look up here, this thing called execute, it logs what it runs, it checks whether the first command exists and is executable. But I'd rather find out early, before I've wasted half an hour doing something that I'm going to puke halfway through running the code. So this just gives me an earlier way to find out that some of the more exotic commands might not work. But yeah, curl,
call that function yet, though,
make dir, git, make are all things I could check. Curl and make dir are probably on everything. Git and make might not be, especially make. A lot of distros don't include make by default these days for the same reason they don't include GCC. People have forgotten how to build things. But yeah, that's a good point. I should be checking for more things there. I haven't gotten a chance to put them all in yet.
I kind of thought you'd be using execute all over the place, but I saw you calling git without it. Is the idea you would
have
all of your
normally what I would do? Well, normally what I do is, oops. what I would normally do, what you see here, what I do for these, this is a cute trick. This is an example of compiling. This is dynamically compiled bash. Can you see what this is doing?
No.
Curl and maker are the things I'm looking for in the shell, right? So I'm going to set J equal to which. The which command returns the absolute path to an executable that was found on your path. If which doesn't return something, it wasn't there. So I can't run the program. If it's not readable and it's not executable, it's not going to run. After that, $I is CURL. $J is the absolute path to that program. By evaling it, I'm evaling the statement curl equals, bin curl, bin user bin curl, whatever the path actually is. This is installing a variable into the code whose name matches the executable. So back down here, I say $curl this, $Perl. This is an absolute path. It also means that it's harder for people to put malicious code in an off-ball location and maybe do something to hack my, if they hack my path or whatever, I'm going to see what the absolute paths are as I'm running them. And I can say, wait a minute, why did this Perl come from user local bin? Who the hell installed something there? So partly this security people will do this often, that they say you always must use absolute paths for everything you ever run. And normally you would say curl equals and set it to a read only at the top of the code so that all of your shell executables use absolute paths. And that way, a classic way of hacking your system is someone takes a script that runs as a privileged user and they will hack its path to include an off-ball location. And then they will put an innocuous looking program in user local bin curl that installs a backdoor and then deletes itself and then runs execs the real user bin curl with its arguments. And now the file is gone off your file system, but it installed a backdoor. So usually it's a good idea to validate that your paths, the absolute paths to what you want, are in the right places. This hack does not do that. All it does is verify that these things exist in the system and that I'm not going to puke when I go to run them, and then runs them with absolute paths so that if my path were screwed up during the execution, I'd still have valid paths. I don't do it here, but there are times when you write shellcode and you will actually hack the path during the executing of the shellcode. And then you find that, oh yeah, the path that I need for this cuts off that. And you find it's easier to store the absolute paths and know that you'll get the stuff later. And again, I do a maker here with a $maker minus P minus V, just so that I know it's an absolute path.
I think you just have Perl on your brain. You just like putting $signs everywhere.
Well, no, the Git and there are a couple of others. There's Git and there are a few things I run in here that I should have put there, but I hacked this on the fly a couple of hours ago. I wrote this from top to bottom in one sitting.
I've run into many of the same recommendations about using the absolute path, and I agree and parrot. I was gonna say if you were sanitizing your path.
Well, what you would do is this.
Hold on.
Here.
Can I finish?
Oh, sorry.
but you spoke to the fact you're using the witch to find it in your path, and it does not protect absolute. Somebody could still mess with it before you run, but it does protect if the code you're running breaks your path to things like. So you answered.
Well, here's what you do. You do this. You up caret bin or user bin. And let's just say, I'm only going to run things that live under bin and user bin, period. There you go. So basically, if I don't run something that begins in bin or user bin, it won't run. I will be denied the option to run it. So what this says is basically if everywhere I use make, let's see, make. There we go. Okay. At this point, all the shell stuff that I'm running is only going to be run out of bin and user bin. Or let's say opt bin, because I know I have stuff in there. Can you see what this is doing?
Hey, how come you're able to put
here,
that double that or on the on another line? Does that not work?
Where's the, oh no, that's called a typo.
Oh, okay. I was like, how are you doing that?
Yeah, no, you don't. But basically what this says is if the thing I found, well, actually I would put this up here. So start getting a witch. If it doesn't match my path RX, puke. Okay, so now my curl maker make git. These are all the sorts of things. Now, I know for this piece of shellcode only runs as myself. Unlike a lot of people, I'm not stupid. I didn't lock down the opt directory so that only root can access it. So I don't need to be super user to maintain most of this machine. If you're a bin user, you can install things into opt and user local. And what's important about that is there aren't very many people in the bin group, but none of us has to do an SU-do. So you can always tell who did everything because the actual correct username is associated with everything that gets installed. The other important thing about that is because I'm not super user, if I run something and someone tries to run malicious code to install things in bin or user bin, they can't. It's going to puke. So because of the way I set these systems up, with graduated privileges, there are a group of people who can install things into opt that can't install things into bin and sbin and user bin or anywhere under user. Basically, they can't write to the stuff that's important on the root volume. But that makes it a lot easier to run this kind of stuff because this is extraneous. If somebody did something malicious, probably all they'd be able to do is cause my code to puke by not being able to write to the wrong place, and I'd see that it was there. A lot of people lock things way too far down. And as a result, you see all the examples in the books to have SU do something something in front. if you're SU doing everything everywhere, other than starting something on a port less than 1024 or 1000, excuse me, or trying to start and stop daemons that have higher privileges. And most of the daemons give up the privileges. You're just as well off having a user Postgres and giving people the right to SU do to the Postgres user and use the Postgres user to start and stop everything. Done. If I have shellcode that is SUID Postgres, the only thing it can do is start and stop the database. Somebody could include malicious code to, delete everything, but they can do a lot less damage to me than if they're SUID to root. A lot of the idiots that have written generations of code assume that the user ID is root. There is nothing special about the name root. I know you had talked about this once before. 0 is the magic number. If your user ID is 0, you have super user privileges. So the classic way somebody hacks your system is they put something in the middle of the password file that's Joe Blow, and they just change Joe Blow's user ID to 0. And they're still Joe Blow. If you do an LS, everything on the file system is owned by Joe Blow. But Joe Blow is a super user. There's nothing special about the name root. Lots of stuff now checks for the name root. And so you have to be root. And root is, if you leave, for example, an SSH server, if you run the daemon running on port 22, you will spend 1/3 of your CPU time doing nothing more than getting brute force attempts on the user ID root. Simple fix. Well, other than changing the port, take the name root and call it bugger off, schmuck. Cram it into one word and stick it at the top of your password file. Nobody's going to try and fake bugger off schmuck. They don't know what exists. It is a certain level of security through obscurity, but it certainly is better than having root exposed because everyone knows it's there. But anyway, yeah, this is a quick and dirty way to make sure that everything's just run the way it's supposed to be.
What do you think about instead of failing because those aren't installed? What do you think about installing them? Because I've seen some scripts that just install
no friggin'
all
way.
the dependencies. 3
reasons. There are a couple of reasons. One is, I just told you, I'm running this as myself. I don't have privileges to install stuff like that. I want to separate the privileges. I am in a group that has the ability to write to the opt Perl directory and let's say opt Postgres. Maybe there is no other directory that I'm allowed, the system directory that contains executables that I'm allowed to install into. That would be smart. Now I can have my DBA be a member of the Postgres group, and that person then has access to the Postgres files without doing SUDO. They have access to opt Postgres where the stuff is installed if they need to maintain it. I might go into the SU doers and make it so that they can SU to Postgres without having to give a password. But they don't have to be super user. You want to dick around with the Git, you're going to have to do an SU, and this doesn't. And I don't want to escalate the privileges of something like this that's a one-off hack. Because there are too many ways, like somebody noticed I hadn't checked Git. This, code like this that's a top to bottom install script is taking the time to make it boilerplate enough that it was safe to run it as super user would take me forever. I need to get this done. So the first step to doing that is making sure that it can't do anything unfortunate if I screw it up. It will puke. It won't wipe out the root volume. Because this might do an RM-RF to clean up a build directory. And the only way to do that is separate the privileges so that it doesn't need to be run as super user. Did that make sense the way I said it?
Yep, sure did. Can we see where you're calling the execute method? I don't think we've seen that yet.
Oh, execute. Right here. So for example, well, there are better examples. So here's a good example. And this gets back into arrays. This is an array. This installs the cpan-m executable. cpan-m is a package installer. The nasty thing about package installers is if you have to install them, you need a package installer. To install the package installer, that you have to install the installer to install the package installer installing the anyway. The guy that wrote this got out of it. The actual program, oops. If you look at this, this is a this thing is the version that basically the program arrives fat packed. And so what you curl is something that can run, it can execute itself, and it executes itself to extract itself. So it's a self-extracting package installer. So if I grab it off the net and I pipe it into Perl, it will execute and install itself. How's that for cute?
Variant of a shell.
So to install it, what I do is I run $curl and I give it the argument and I give it a pipe, and then I run Perl, and Perl is running its standard in as the program. The double dash, because Perl uses getopt, says, Perl, do not treat the remainder of this as arguments to the Perl executable. Leave those on the stack for the running code that Perl is executing. Do you see what I'm saying there? So when Perl runs getopt, Perl's getopt is going to see dash, and a bare dash Perl says, I know what that means. That means I'm going to read my executing program from standard in. Oh, here's double dash. I'm going to stop chewing through the stack. I'm going to leave what's left in Perl's argv. I'm going to leave the rest of the stack alone for the code that I'm running. And then this thing sees its own name and it says, oh, you want me to install the cpan minus application. And then it goes out to cpan and actually gets a copy of itself and installs it properly. So this is an array purely because if I try and put this on one line, it wraps. So being able to break it out this way, I think makes these more readable. And you'll see where I do the configuration, config args up here. This is another case. So these are all the arguments I'm giving to the configuration execution. But I find it easier to read these with a little more white space, line things up, put the ones without arguments at the front, do whatever. And then I run this. I find config, and right now I'm at the point of testing this. Actually, I'm done testing that. And then I run the configure that I found with its arguments, and I could pass this to execute.
So execute's
And then
gonna
if it
log
puked,
that.
it would tell me.
So execute's gonna log that, and so when it gets to the config args, is it gonna put like 2 tabs of white space before every?
No, it doesn't need to.
Well, what about the?
It
Well, 'cause
just
there's,
runs
like,
whatever it was
array.
given.
What's that?
It runs. This thing is going to print out $splat, which is all of its arguments.
Yeah,
It's going to check that the first argument is executable, that exists, that the first argument is executable, and that the first argument has non-zero size. Any one of those things is very likely to cause this to fail, but at least this way I get a more reasonable error message from it.
Mm-hmm.
At that point, I eval running whatever that was. That's going to take the bash compiler. It's going to expand that text. It's going to parse it in the normal way that it would, the same way it's going to pass it through the same parser and compiler that this line went through. And whatever the result of that is, it's going to execute it. And if it returns, now I use this for executing shell commands. So if it returns non-zero, I say it was fatal, and I say what executable it was, and what the error message.
But
This
in
is
that
good
array,
enough
though,
for
you
something
had,
running single string.
yeah, so in that array, though, you had a bunch of white space before each item. And I was just wondering
Right.
if that will be printed out in the log or if that's like trimmed.
No, that gets flattened out. What happens, okay, what happens is, what happens is the parser, again, Bash is Bash is an interpreted language. Every time Bash sees a line, it has to figure out what it means, because you've got something like this where I've got it's executed this config da 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 da. I could just put this. This would execute just fine, because the compiler, the interpreter would hit that line and say, "Oh, I see a $sign. I will expand that. I see a $sign. I see a curly brace. I will look inside the curly brace. I will find a symbol. Ooh, that's got a star in it. That says take everything in this array and paste it together with a space and generate one long string out of it."
I have two.
Now, when the interpreter read this, it discarded all the extra space. So the first argument is -DES. The second argument is this. The third argument is that. The fourth argument is -D pager. The fifth argument is whatever is inside these quotes. And then this one is the Perl directory, and then this one is whatever's in these quotes is one argument. All the other white space was discarded when the interpreter tried to read in the definitions of these lines. There's a variable called IFS, input field separator. Which is a string. And you'll see that it's a space and a tab and a new line. Well, yeah, the echo put its own stuff in. But 2027-0A are space and tab and new line. And this here was a vertical tab. 09 is a vertical tab. Oh, gods. Machines, I don't include all the man pages. 09 is horizontal tab. New line is 0A.
All type.
Space is 32 hex. No, it's 32 decimal, excuse me.
Too small.
Space is 32 decimal. And I think, and vertical tab is 0 Bravo. Form feed is 0 Charlie. I think that's actually 0 Charlie is what's in there. But basically what happens is whatever the contents of that variable are, as Bash is reading through the source code, it will break apart the line by discarding the contents of this and using them as separators. And repeats are just separators, if that made any sense. Tab, new line, space tab and new line. 20 is you can't see the space there, but tab, space, and new line are the normal separators when the interpreter is executing. There are times when that is handy to change. There was one time I was writing bash code, and it had to read a massive piece of JSON as a single item into an array. And what I did is I separated the elements of the array with tildes and set IFS equal to tilde. By doing that, when there was a subroutine that had a line in it, and it had a local IFS equal this. And then it had, big struct. And then it was just a long quoted, it was a long string of stuff that had something and a tilde and something and a tilde. And what I got was all this stuff in between unmodified. And it allowed me to have, basically it was a here, actually it was a here script, a here string. So it was big equal something like that. And then if you've seen how here scripts work, if not, there was a thing I did before on it, but there was a bunch of lines with the word JSON on the left margin below it. And that huge thing was just one piece of text that I could cut and paste out of whatever crazy place I got it. But the only thing that broke the elements apart were tildes. All the new lines and tabs and white space inside of it were ignored, and they were treated, each item had all of its white space intact because the separators were tildes. You almost never have to change this. But what happens here is, because IFS has got new lines and spaces and tabs in it, all the spaces and all the new lines are discarded and used as separators. So whatever isn't white space between these parens, each of those is an individual argument. Did that make sense the way I said it?
Yep, very thorough. Thank you.
So now what happens is I get down here and I execute config and this. Yeah, I can do one long string. It's going to check that the configuration is a non-zero executable, non-zero sized readable executable. If anything, if I get an error, it's going to print it as being from this. But then these are going to be passed to it as one long string and then evaluated and passed down to the shell. Now, what I might have to actually do is this, because this is going to be evaluated twice. These double quotes are going to expand once when this line is executed. This line is going to expand to the path to that config executable, /configure, followed by all the rest of this in single quotes. When that means that it won't be broken up and reinterpreted by the shell when it gets to that eval statement. That eval statement is then going to get all of this as one big thing, and it's going to push it all in. And that way, it'll preserve all the quotes that are in there. So this will remain as one object on the stack. This is going to be $1, the config. $2, $3, $4, $5, $6 is all of this. If that made any sense. So when you use eval, because you're double interpreting things, you have to be really careful about how you quote things. That's why, and again, there was a talk I did, if you look it up on SlideShare, on dealing with that, and I can do it again if Gary needs somebody in another month. But the trick here is you can use set-VX when you're running the code, and it will show you every stage of parsing this. And when you're doing stuff like that with evals, it's a good idea to run it. And you saw that before, like this thing. what I'll do to check it is I'll do a set minus dx here. And then exit 1. And exit 1 is non-zero, but most of the time, if you do an exit 1, it's supposed to indicate something more innocuous than like 255. Yeah, exit minus 1 is 255. So an exit 1, like if you exit from a help function, if you exit with 1, somebody knows you didn't puke, which is minus 1, or larger than 1, but you also didn't finish. So it's like the difference in a warning and an error.
So am I remembering right that single quotes are literal?
Single quotes are non-interpolating. Double quotes are interpolating. So double quote $Perl-D double quote is going to take the Perl directory and expand it from the variable and leave it as one string. Actually, these quotes here, those were extraneous because I know that any directory, anything in the file system isn't going to be broken up into multiple pieces or it wouldn't be a valid file. The oldest trick in the world is you drive some Unix newbie crazy by creating a file called readme space. Remove it. No, remove it. And eventually they learn tab completion. They just type, RM R tab and it just gets rid of it. They don't see the space. But people that try and type it or cut and paste it, it just never removes because the shell parses out the space. They go crazy. Or create a file called remove space me, and until you learn quoting, it fries you. But this is non-interpolating. So if I had a variable in here, let's say I had, $foo, the actual literal $foo would be passed out of that.
Okay, so what
Whereas
about
here,
line
this is
277 though, where we have the double quotes on the outside and the single quotes on the inside. So does this mean
that is going to take, well, this is interpolating, right? This is going to interpolate all the variables in it. If I had, let's just say I had this, right? Double quote says, preserve white space, preserve special characters. From here to there is one argument. This is going to be one string stored within the bash structure. Does that make sense? It's not going to be broken up into separate elements. It's one string.
Right. $1.
The contents of that string, the first thing bash is going to do is look at in its symbol table and find that config is defined. If it's not defined, you're going to get empty. But it's going to find config and it's going to expand the value of config. It's going to find a literal space. It's going to stuff a space after whatever it expands it to. It's going to find a literal quote. It's going to stick that in. It's going to see a $, which means expansion time, but now it's going to see a curly brace. So it knows there's a little bit more going on here. So it's going to read, it's going to say, oh, I find word characters. So $open curly word means this is a variable. The square bracket tells it, I'm looking for something that is either an array or a hash. This is array or he calls them associative arrays. So whatever it is, the star says take its contents. If it's a numeric array, you're just going to get the pieces. This is 0, 1, 2, 3, 4, 5. So it's going to get just stacked together. If this was an associative array, you get the values in the lexical order of their keys, and you get back this list. So each element of config args is going to be expanded one by 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 one. And then I'm going to stick there's a literal here, so I'm going to stick a literal quote on the end of it. And that entire string is going to be passed to execute as one argument. So it's going to have one argument, $1. Now, I don't want that.
But hold on a second though. So with how you had it before, right? It gets it has
Right.
a double quote.
This
It
is
gets to
$1.
it gets to the
This
single
is
quote.
$1.
And then how come when it
Right.
sees a single quote, it doesn't say, "Oh, there's a single quote
Because
here."
it's inside of the
rest-
double quotes.
Okay.
This is
So if you have
one
a
character
single
string.
inside of a double.
Double quote starts an interpolated string.
Even if
This
there's
is
quotes
one
inside of it.
interpolated string.
Gotcha. And so
At that point, the quotes are literals that are interpolated into the final string as literals. The $sign inside of the interpolated says, figure out what the $sign, well, an unescaped $sign inside of single quotes says, whatever follows me is a variable. So far, so good?
no.
Now, it might be a variable like this. That's just a simple variable. It's plural D. And you look it up in the symbol table and you get a scalar back and you stick it into the string. It
Okay.
might be something a little more complicated like this thing.
Okay, but what about this? Because this config args is global, right? It's a global array.
Right. No,
So
it's
if you
not.
said-
It is not. It is not. It's not global. What do you see in front of it?
Typeset, but you're not passing any. R stands for read only and A is array, right? You're not saying
Right, right.
local.
If you typeset something inside of a subroutine, then it is local to that subroutine.
Oh, it's automatically
Period.
local. Okay, but if you made
Yeah.
that global,
If you just declare a variable without typesetting it or declaring it local, and there's an alias for typeset called declare that is, I forgot what language used that. If you formally declare a variable using local or typeset inside of a subroutine, then that variable is local. You can, if you look in the bash man page, there we go. Typeset minus P name equal value. Now, each name is, this is an indexed array, associative arrays. I can typeset something to a function and say, if somebody tries to create a variable with this name, puke, you can create things that are integers, and it will only take things that look integer-ish. You can have a variable that always stores things as, now you can say something is lowercase and read-only, so you can assign it once. It will be lowercase and done. Tracing is for debugging. Every time you touch it, it'll call a trap that will dump out the variable. This will uppercase everything, and minus X is export, which says if you fork anything that's, if you do a typeset minus X or you type export and a variable name equals something, then that variable will be pushed into the environment of a fork. And the other thing you can do, they have indirect variables too, is another thing you can declare. But you can declare a variable that every place it's used, it references another variable, which is great for dynamic code. But typeset is local. So for example, I couldn't do a typeset minus, if you look here in the command line, I could not say here if I said typeset minus R recycle equal 1, I would fry myself because now recycle wouldn't be available outside of this subroutine. Did that make sense?
yeah, you got to add the -G.
Yeah. Oh, there we go.
Yeah, see, it doesn't list it in the
Ah.
list of arguments, but if you look up in like two sentences
Yeah,
up
you
in
have to look it up
-A,
elsewhere. Yeah, you find, yeah, you have minus G is global, and one of these is used for references.
Stop. Okay, the G is mentioned right there.
okay, but so okay.
AFR, no, well,
Stop.
AFILRTUX. It would have been nice
It's not listed,
if
but
Stallman had put the rest of them in here,
Steven,
but yes,
scroll down about 4 lines.
I get it.
Stop. Okay, right there.
Unless the G option is defined, if a variable name is followed by the equals value is set to the value. I get it.
Okay.
But that doesn't say what global does.
it's actually two sentences above the top option. It says what it does. But
Yeah,
it doesn't matter.
But it's not down here in the middle, which is what makes reading this man page such a pain in the butt.
Okay, you're right.
Yes, you could do a minus G on it, and that was how you could do it there. But at a certain point, trying to do this in hopefully less than an hour, which I've probably way overrun by now.
Yeah, by 100%.
So the dash, but if it was global though, then you wouldn't have to quote it at all, right? Because you could just pass, or you can only quote it in double quotes. Or no, then you could no, okay, let me rephrase. So if that config args array was global, you could put it in single quotes without the double quotes on the outside, and it would pass the literal string $config args, et cetera, into the execute function. And since it can access that variable, it would expand it when it's calling during eval. No.
Yes, you could do a typeset minus G and do all that minus R, and that would work. But when you start doing that, people go.
Steve, we lose you?
I know it keeps muting me. It's trying to tell me something, I guess.
Yeah, your audio is getting really weird. It keeps cutting out.
Yeah, I'm
It
missing.
keeps muting me. Will somebody who's the fucking moderator just click the unmute button for me? It doesn't like me keeping myself unmuted. It's getting confused with life. I don't know why.
It's not showing you as muted.
Yeah, but it keeps telling me that you are muted anyway.
Hardware.
Blame it on gremlins. Somebody didn't do the donut dance. But anyway, does the notion that this is going to end up as one scalar string on the argument list to execute. The double quotes mean that everything in it will be interpolated as part of the result. Anything that starts with an unescaped $sign is going to be treated as a variable, and the contents of that variable will be expanded, interpolated into the string. Anything that isn't a variable is going to be passed through as is, as a single quote. Now, one thing about double quotes, I could put a tab here, and that \t is another thing that gets interpolated along with the variables. So I could put a literal tab in there if I thought it looked pretty. In processing the eval, that tab would be stripped out because tabs are part of IFS, and the eval would say tab, ignore that, use it as a separator, so it wouldn't matter. But this execute is going to get two arguments, config, and whatever the glommed up result of these double quotes is. The trick is it's going to arrive as a single quote. That is still one argument. It just doesn't have the single quotes in it. The point of the single quotes is here. If you look at it, $1 is that configuration executable, right? When it does the $* here, I'm not actually using $2 explicitly. If I'm not using, then actually probably I can get away without them. That's the kind of thing you've got to check with these evals, because there are single quoted strings that are nested inside there. So I may want, eval, I want it to treat all of $splat as a single argument. I might get away with, I think I actually might be able to get away without the extra quotes. Evals get messy that way. This, for example, $jobs make minus WK, this is not passing it through execute, because I wrote this line of code before I wrote the execute function. And because it kind of breaks the way execute works, because $1 is test jobs equal jobs, which is not what I want to report the error as. So here I just ran it. And then Perl dbin Perl. This just checks that the Perl was installed. So this says, okay, the thing that I thought I was installing got installed. The bin directory is the dir name of that, and I execute h to ph. And again, this here is an absolute path. So if somebody has h to ph in my user local or something, it's not going to affect my life. And then I'm installing the utilities, which gets cpanm. And notice here there's a pipe. So that pipe is going to be passed through as a literal. So this is going to expand to curl minus L this pipe Perl blah, blah, blah. So this is actually going to execute curl piping it into Perl. Does that make sense?
Sounds confusing.
No, it's I could have, if I had typed here curl minus L okay, everyone knows what a pipe does, right?
Yeah.
Well, this is going to take Perl, it's going to take curl and put the output of it into Perl. This is going to do exactly the same thing when it gets to the eval. Eval is going to take these as 4 separate arguments, glom them together with a piece of white space each, and then execute it. But this time, the pipe is going to be part of one long string. I had to single quote it there, double quotes will work too, or I had to escape it, so that the shell doesn't try to read the pipe as a valid meta character and try and complain that there's a pipe execute, pipe in the middle of a variable definition. So inside of the quotes, this pipe is just one more character. So then I execute this, and then I check to make sure that it exists. At that point, I can run cpan to get cpan outdated, and then I execute cpan outdated and pipe the result into cpanm. And that takes all the names of all the modules that are more recent in cpan and pushes them into cpanm where they get updated and reinstalled. Which is how you keep your stuff up to date, at least with cpanm. And then I have to get to the modules, which has to take my existing Perl, which is the one on my path, and then my modules, there's a module called xdutils installed that will get a list of modules that have been installed since the release was created. And so what I do is I execute a thing in Perl to avoid what Larry Wall calls leaning twigs syndrome. You've all seen this. If you want to interpolate, if you've got this and you want to have, you said, you get that kind of mess because you have to escape all the double quotes inside the double quotes to get them to be literal double quotes. To avoid that, Perl has a notation. QQ is a double quoted string, and you can use slashes, you can use pipes, you use anything that doesn't appear inside the quotes, and then everything inside of it until the next one of these, that's my string. And then you don't have leaning twig syndrome with all the backslashes, because then if you have something double interpolated, you have to escape the escapes, then you have to backslash it. It's a mess. So what this basically allows me to do is have a double quoted string inside of it without having to put a quote that's going to be interpolated funny by the shell. So this is going to create an object and call its modules method. And if I take that, what this does is it executes this. Oops, I just noticed a bug in the code.
Dropped you again?
Oh, fucking hate.
No, what happens is this is a list. So actually, this is a subshell. This says, and you can get the same effect in Perl if you type QX blah. You can say this in Perl. And QX is the same thing as they're like backticks, but it saves you again from quoting problems. But this says execute this using the shell, take its output, and hand it back as a scalar. And here I just store it in a variable. The same thing happens in Bash if you have a $open close paren that says run this and return its output. In this case, I'm storing it as, so I can say, actually, this should be typeset minus R mod. Makes it clear what I'm doing. At that point, this gets converted to a list of single words. At that point, $mods without any array stuff on it looks at the first element. Well, if there's nothing in the first element, something went wrong. Peachy. At this point, I can take each of the mods, expand it as a separate word, and I install each of them one by one. And I could do execute on that too, but cpanm has a lot of its own logging, and it will tell me enough about what it's doing that I don't need to go that far. And this will take all of the modules that appear in my current path version of Perl, and it will reinstall them into the new one, because this cpanm is an absolute path to the Perl I just installed. If that made any sense. So this is looking at the Perl that is on my path, which the way the paths here are set up, you see this opt bin at the front of it? That's a bit of a hack I created 20 years, 30 years ago. That's a long time ago. So you'll notice that everything in this directory is a symlink. Just about. This isn't. But what happens is they're all, this takes the part of Postgres and Perl and whatever else on PG Bouncer. This puts all the things we actually use in one place. So instead of having to have opt Postgres bin, opt Perl bin, opt GCC bin, opt G++ bin, opt, blah, blah, blah. You just take the portions of what you need and put them in opt bin and symlink them into dot something bin. And it makes it a lot easier to maintain your path because all it has is opt bin at the front of it. So this is going to go through and install all the modules, and then I'm done. And I'll usually put good night at the end of the. I've never seen any other programs that use good night. So if I log that, I can tell that it's my program ending in a log with 50 programs dumping into the system logs. But anyway, I can do sandbox build Perl 5. That is a Git repo. Right. And CentOS is so ancient it can't do a less on a directory. But at that point, I can do / initdb sandbox build Perl 5. Let's see if this works. Oops. Oh, what am I doing in initdb? So this is now running the configure. Bloody cursor, there it is. So this, you'll see here, install Perl, building in this, my working directory, install from this. Perl version is 540, which I know is correct, so it's going to put it there. It's installing the Perl 4. Remember, I put that set -vx in there so I could see what it was doing. And that did what, that showed me what I wanted. See that eval, see this eval here? Eval configure, and you see how all of these get expanded out. Now what I notice is I don't have the quotes that I wanted here. But probably what I need to do. Yeah, this should be that. And this should be that. There's nothing to interpolate, so there's no harm in putting double quotes. Otherwise, what I'd have to do is have it this, and then I'd have to escape these. Yeah, sorry about all the typos. So they rebuilt my spine out of spare parts from dead people a couple of months ago, and I'm still having problems with coordination. But because these are all literals, there's no harm in putting a string of literals in double quotes. So this is going to preserve the single quote. So when it's expanded inside the eval is going to get it as a single quote entry. So you'll be able to see that here instead of exiting. Let's just do set minus. Did I do that right? Yeah. Yeah, it goes pretty fast. Yeah. Um, oh, this is just doing the cleanups now. So now, yeah, you'll see here, you see where it's got this escaped quote here? That's showing me that the quotes were passed through to the eval. So if you look here, see what says this thing? You see now here, when you look at this, you see that you can see the single quotes are around this and the single quotes are around that. So these, when you look at it in the expanded version, you get this escaped garbage, but this is showing me that those quotes made it into the eval statement. So you see here, this is the actual line that's going to be executed. You can figure, and you'll see now, pager is user bin less minus rm no init, but now this is single quoted, so it's one argument to the minus d pager. And this, the prefix has no quotes, and optimize is minus 03 mark equal native pipe, and don't get on my case about minus 02 versus minus 03. But then that's going to be passed down as a single literal. And this is all of the sanity checks that Perl does on the. So you can see now it's compiling everything. On my server here, it takes about 3.5 minutes to compile Perl and another 5 minutes to test it. One interesting thing about Perl, by the way, that is different than Perl and Reiku, that are different from pretty much every other language. If you install a module with Perl, the tests are actually run in every environment. And that uncovers a lot of bugs because you can't, nobody's got all the machinery that at least Perl runs on, including VMS. I just don't have access to a VMS server. So there's a neat thing called cpan reporter that sends back the results of that to a central place where the errors are grouped together. So every night I get a report of all the places where my stuff failed to compile on some weird ass operating system or some more modern set of libraries that I might have. And that can be a really big help in keeping track of things. But when you run Perl to test it, there are 13,000 tests that it runs before it installs. I mean, it's a hideously large number when you get at all the tests and the subtests and all the rest of it. Yeah, this is running on a 2 CPU VM in AWS. If I ran the same thing here, you can see one thing. This is actually a cute trick for, oh, yeah, I need to get another one of these. Here you go. This may be hard to read, but if you go into the proc CPU info file and you grep MHZ out of it, you're going to get one line for every processor. See, we're into the tests now. If you count that, that is the number of cores that you have available, which is a really good. So what I then do is when I run the make, you'll see this is jobs. I'll make minus J jobs, which runs that many in parallel. So basically I'll swallow all the cores. And I do the same thing here with the tests. The number of test jobs running is jobs. I could do this by exporting test jobs and then running the make as a separate option. But that's why I didn't use execute, because $1 would be test jobs equal jobs, which is not very helpful. And if you make all test install in that order, you could do make install that'll run the rest of them, but then it's a little more explicit if it pukes which layer it puked in. And this is running, it's about a third of the way through the tests already. But this is what it looks like building Perl. Did somebody say something? It broke up. Hopefully I sound better than that to you guys.
Yeah, no, I didn't hear anything breaking up. So.
Oh, I'm hearing some background noise of some sort then. But yeah, you could. Beware, by the way, if you write out a running piece of bash code, bash will reload the file and reinterpret it from the point of the offset it was at. So you can be working on a bash script and accidentally save it from the editor and break a running piece of code. But we're right up to here now, where it's building. So it's right here. And then the next thing it's going to do is sanity check whether the Perl directory's bin Perl is there. For that file, does it exist? Is it execute? Does it have non-zero size? If so, then my Perl is equal to that thing. And that's but that one isn't on my path yet because it's not symlinked into opt bin yet. Eventually what I'll do is so you'll see right now there's 3.41 is where everything lives. So in a little while, what I'll end up doing is rn star ffsv 5.40.0 / dot. And that is how I upgrade the version of Perl. If I want to downgrade it, I link 534.1 start to dot. And then what happens because opt bin Perl, well, that actually should refer to opt Perl bin. That got screwed up when it got put in. That was another script I did that didn't do it right. Oops. Those should be symlinked as just Perl bin Perl. And that way, if I upgrade it here, it upgrades it on everyone's path in one step. But should adjust that actually. Yeah, see, this is done the right way. What the hell was I thinking when I did those?
Doing basic.
This is a neat notation, by the way. This is part of dealing with the shell in bash. This is a list of alternations. This is going to be expanded to all of these. And these can have these actually can have multiple alternations within them. And we've all dealt with it. You've got something where you've got 800 subdirectories and there are different levels and everything else. With these things, you can so you can see where this is going to expand to all of those. If there was Perl, this could be Perl bin lib, and it's going to expand to all of those. If you had Perl bin lib, So this is you can see how this makes it really easy to generate pretty large lists of things that have subdirectories or subtypes or files that are in multiple places, with pretty straightforward notation, because anything inside the curlies is just expanded as is. You can also do so it'll do alphabetic and numeric increment with dot dots, which is again is a nice way if you wanted to make, classic thing is you break a directory down and to keep the files in a reasonable space, you take the first two letters of every file and then you put every file in a subdirectory under its first two letters. So a file ABC would be in the directory A, subdirectory B as ABC. So I can do that'll make it interesting. Okay, that's how hard it is to make all of the subdirectories. But it's things like this, because again, that could have been user bin, live something. You can nest subdirectories. You can make fairly complicated collections of directories. Did I push it now? This is another nice thing. Oh. Yeah, there it is. One of the classic things you want to do is keep just enough information going on the screen so that you don't get a timeout for not having any output, but you don't want the screen to scroll forever. So what snooze does is it prints the current time, and then every second it prints the time until it gets a return and stops. What's sexy about that, the cute trick here is by doing a carriage return and then the date and a carriage return. What that does is it prints the date at left justified on every line. If you've got something running in the background and it generates output, this carriage return will put you at the start of the next line and then print it. So you won't get the date stuck on the end of a line. They're always left justified. And then anything that comes out is going to overwrite the current date and go, and then the next date's going to go below that. So if you get data, if you get stuff appearing on the screen, you can tell when the hell it happened. Because every second, this thing's going to update the screen. But with a 1 second timeout, if you hit return, if you type anything, it'll do a read and it'll break. It just ignores the input. But until it sees some keystrokes, it's going to sit here. I can type X, and you can see if there's some output, it'll just keep going. If I hit return, it exits. But I do this, the first one shows me when I started. If I just walk up here, I can tell how long it's been snoozed. And this will keep a terminal up, in Amazon indefinitely, because there's outputs, and they're not going to close it. Ooh, we're getting through most of the tests now. But anyway, I don't know if anyone wants to watch the rest of these test runs, because it gets kind of boring. But there are thousands and thousands of tests that Perl runs every time it does an install. And then all the modules run their own tests every time they're installed. So you can if people write decent tests for the modules, no matter how crazy your particular environment is or how customized it is, you're sure that the stuff has at least been tested in your environment before you try to run it. If you look at every other language, Rust, Python, Scala, if you install modules, they all just plop themselves on the disk and they're done. They don't actually run all of their author tests. And you can see here, some of these are skipped because we're not on BIOS or we're not on VMS or we're not on Windows 32. So unnecessary tests are skipped. Some of these are skipped because they're only run by the authors and they have to have a special switch so they just don't get executed. But they make it a lot safer to run this because everything is examined before you use it. Anyway, Gary, I promise I'm going to go back through and clean up all the typos and oops, like in this thing. And
but you did a wonderful job putting stuff together. I mean, it was a great
well, thank you.
technical stuff.
But yeah, this was. I wanted to get some more stuff in here. I just didn't have time to write it. Blew about 4 hours on this last night. Where are all the bugs? Was this helpful to anybody?
Definitely.
Yep.
Well, for you, Garrett, was this helpful for, how many people are awake? Just everyone unmute yourselves and at least say hello. Come on.
Hello.
Getting late.
Hello.
Hello, we got a couple of people awake at least. Yeah, I gotta go back and proof this. Typeset minus R, locals minus RV. Where were all the
Hey,
here we go.
let me suggest, although
We give up. Nobody wants to watch me proofread this, I don't think, but unless somebody can help me find the errors, there's
I think a few
a
people.
couple of these had $1s in them.
We got a couple more people for your Eastern time zone, and for them, as for you, it's getting to be 10:30. So we probably should look wrapping up here. I would like to make a couple of brief announcements. First off, very apropos to your talk tonight. On last Tuesday, the 12th of the month, there's an entry on our calendar, and also we've got a little discussion between Denise Steen and myself and discuss. Professor Tom Kurtz passed away. He was a professor at Dartmouth, and he was one of the co-creators of the BASIC language. He was 96 years old, I think, when he passed away. And the other
Isn't it hard to have him speak?
Yeah. But the other reason why it's very apropos to your talk tonight is the other thing that he was co-creator of was the Dartmouth time sharing system. That, of course, done on a GE mainframe, and the GE time sharing developers said, "Oh shit, the academic people seem to have a lot of things that we don't have in the commercial attempt at time sharing." And so it was really the integration of the Dartmouth time sharing system with the General Electric commercial product that became time sharing on GCOS, which of course is what was copied, emulated by the original Unix developers. There's a lot of the stuff that was already.
Well, actually, where it was the first place it appeared was LPARS. So the first people that actually made use of it was IBM mainframes. That's time sharing on those systems became the little boxes that LPARS were built out of. If anyone here has ever played with IBM. And then the funny thing is the time sharing on Unix took a completely different tack that was a lot less protective. And then people realized that was bad. And since then we've had cheroots and jails and everything and all the different, Sun had a version and cheroot. And finally, what's interesting about Linux, coming 70s, 80s, 90s, 50 years later, what's fun about it is that the current system on Linux that allows for Docker and all the rest of these is actually implemented from IBM's LPAR system using process groups. Instead of isolating the process, they isolate the process group. And that whole design was taken from IBM's LPARs that were taken from that Dartmouth layout.
I'm sorry, taken from the IBM design, and the last part of that sentence was
the IBM design was based on that old Dartmouth time sharing idea.
Mhm.
But they did IBM in their LPARs did a much better job of encapsulating the different processes so they couldn't bump into each other. So that, for example, you could have a time shared, their time sharing had much better firewalls between the different processes. And it was considered kind of weird and IBM-ish, the way LPAR, most things are. And the LPARs kind of sat there. And at that point, Unix took a more open approach to the processes that turned out to be a bad idea because they can pollute each other. And so what happened then is we've gone through in Unix lifecycle, I don't know if people have dealt with this, but there were jails, and BSD had jails, and then there were cheroots, and there were all these different ways to try and keep people separate, and none of them worked all that well because malicious people could always get through it. And then finally, the thing that became Docker, what's the TLA for it? I can't think of the command line. CFXC. Anyway, the most modern version of Perl separate process separation that allows you to create the containers that are isolated. Finally, they went back to the way IBM does it. And the difference now is that everyone else tried to separate processes. A cheroot, you cheroot a process. The newer system takes the process group, which is a higher level structure that the processes live within, and it isolates you there. And so it's harder, it's amazingly harder for the process to get out of its container and inspect other parts of the system or pollute them maliciously or accidentally. So it's kind of funny that whole design that went into Unix sat with no one but IBM really using their version. And then IBM, people finally said, but wait, what are we doing wrong? And they went back to IBM's. And that's where the whole, what is going to, someone remind me, I can even senile. There's a 3-letter command that starts up the containers, and nobody uses it because Docker is a wrapper around it.
LXC.
LXC, thank you. I was thinking the wrong letter. See, I wrote the C, I put it at the wrong end of it. If you look at the way LXC is laid out, you define everything at the process group, and then you create your first process. And because the first process begins life inside of its box, it has no way to get out.
And that uses C group file system, right?
Yes, I think. I haven't looked at the guts of it in a while. It did. I don't know if it still does.
Yeah, the newest version only allows C group v2 now, so they're iterating on it.
But again, the distinction is that the thing that is locked in a box starts at the process group level, and then you install your first process into the group. So the process starts out correct. With a cheroot, you take your process and then you cheroot, but the environment, the data structures that describe the process, all of its metadata is left outside the cheroot. And that's how people escape it. Malicious actors can go back to their process group and find things about themselves that they weren't supposed to know. And that's one thing that's gotten Linux a lot more secure. The LXC organization is at a higher level of data structure. I think I got the worst of these done with. If anyone finds any more typos on these, please just tell me. I'll be happy to fix them.
Well, Well, one other announcement that was pointed out to me, it's actually in reference to next month, the new lug meeting month, because of the conflict with the holidays. It is moved to, I believe it's,
Friggin' move Christmas. My God, man.
yeah, I know. So, but I believe the new lug is moved to the 17th of December. So, but it is marked that way on the calendar, or at least it will be. So, as I say, that's next month. This month's new lug is still on Tuesday, like,
Something like that.
Is there anything else that we need say before, except to say thank you very, very much to Stephen? This was a real
Fascinating.
tour de force of.
Well, thank you. I don't know about that, but if anyone gave enough of a damn about this, it will be at speakerdeck.com/Lembark in about oh, come on. Where is the one thing I passionately hate about this thing is they don't have an upload button right where you can see it. And I waste so much friggin' time
We'll also
remembering.
we'll also
Oh, there it is. Uploaded deck. There we go.
archive. We'll also have the reference on the archive that we keep on the home page that will show your talk tonight and the slide deck and the recording that will all be in the archive that's there as well. So,
And it'll be on YouTube next week.
yeah,
Oh, God. Nobody
right.
wants to listen to me, but
okay. Anything else we need to cover? Thank you all very much for coming tonight. Thanks, a big thanks to Steve. Great talk. And the bookend. This has been the November St. Louis Lug Meeting group. Today's date, Thursday, the 24th of November, 20. Our speaker was Stephen Clark. He was talking to us about no, it's not the other
Here you're cutting out.
it's masochism from BSD, but it's how to use getopt and to parse command lines. And
good point. Is there anyone? Published date, category, technology. Give me 2 seconds and I'll be able to paste a link for this if anyone real. Pinned. Yeah, start that one. Video URL. If you want to give me a video URL, I can put this here. Browse and select. So,
Okay, kill recording.
there we go. Get the current version of this. There we go. Oh, God.